All right, well, let's talk about the distributive property. So the distributive property is going to apply anytime you're multiplying a single term by some polynomial in parentheses. So in other words, like if you have a times b plus c, the way I want you to show that distributive property is multiply the term that's on the outside of the parentheses by every single term on the inside. I will, unless I forget, almost every time draw these little arrows when I'm using the distributive property just as a way to indicate that's what I'm doing. So like for instance on number 5, I'm going to multiply both of these two terms inside the parentheses by 4. So 4 times 1 and then 4 times 9x, and that'll get me my simplified expression. If I end up with some like terms after that, then yeah, I need to combine those, but you always want to do the distributive property first, okay? The reason for that is the distributive property is really just an application of multiplication. When you're combining like terms, you're only adding or subtracting, and if you follow the order of operations, multiplication always comes before addition subtraction. So that's why this distributive property step should always come before the combining like terms step. So when I multiply this, 4 times 1 is 4. 4 times 9x is 36x, and there you go. Nothing to combine here because 36x has an x and this one doesn't. So the constant, you're never going to combine with a coefficient with a variable. So let's knock out a few more of these. Number 6, we've got negative 6 times a plus 8. So I'm going to distribute that negative 6. If you have a minus or a negative number in front of the set of parentheses, then you got to make sure that you're carrying that to each term. In other words, like make sure you're not just multiplying by 6, you're multiplying by negative 6. So we get negative 6a minus 6 times 8 is 48. You might see a number on the right side. If you look at number 7, this doesn't look exactly like the last two problems because the singular numbers on the right side, but you can still use the distributive property. Okay, it's just that you're multiplying sort of backwards. Okay, this negative 8 needs to multiply by both negative 4 and negative 3n. So negative 8 times negative 4 would be good, positive 32, very good. And then negative 8 times negative 3n would be a positive 24n. Still no like terms here, so we don't have to worry about combining anything. Looks like we might have to combine some like terms on number 8, though. So for number 8, notice we've got quite a bit going on here. Don't fall into the trap of adding these first. Okay, you've got to follow the order of operations. So if you see like some parentheses being multiplied by something, that's an indication we're doing multiplication. So make sure that you do that distributive property first. Don't try to add these two first, because then you're not following the rules of the operations. So let's distribute the 7 first, and that would give me negative 4 plus 7 minus 21m. And which two terms of these can I combine now? Yeah. Negative 4 and 7. Now, on number 9, it doesn't really look too much like we have a distributive property situation going on here, but we actually do, okay? So when you see a subtraction symbol in front of a set of parentheses, once again, like we talked about before, there's actually an implied 1 there. So this is like minus or negative 1 times what's inside the parentheses. So just make sure that when you see those parentheses, if you see a minus sign in front of it, that you distribute that negative sign. And really what you're doing is you're just multiplying by -1. So make sure to distribute the negative sign. Okay, in other words, distribute a -1. So when I do that, I end up with -2n minus 9 plus 10n. All that does is just flip the signs of everything inside the parentheses. It doesn't like change the absolute value of that number. It just changes the sign of it. So +9 becomes -9, -10n becomes +10n. Once you do that, now we can worry about combining like terms. Okay, we've got two like terms here. We've got the -2n and the 10n. So we can put that together and get how many n's? Yeah, 8n. So 8n minus 9. I'm more interested in problems like number 10, where you've got a lot of stuff going on. All right, we've got two sets of parentheses here. We've got all kinds of terms going on. As far as, how do you structure the order of the steps, make sure you do the distributive property first. Like that should be your first go-to if you ever see a situation that calls for it. Don't worry about combining like terms until after. So I'm going to distribute the 5. And in the same step, see if you guys can handle this, I'm also going to distribute the 2. So I'm going to do 2 distribution steps simultaneously. You'll see that? Okay. Here we go. So distributing the 5 or multiplying the 5 by these two terms will give me -10n plus 20. And then when I distribute the 2, I get plus 2n plus 6. And so here we've got a few like terms to combine. Since I have multiple sets of like terms, I'm going to use that underlying technique. That's not something that, I'm going to take off points if you don't show these little notations, but it's good to have sort of a structure in place for how to deal with that. Okay, so it's just a strategy to keep your work organized. I'm going to underline my n's and then circle my constants so I can kind of really visually see what my like terms are at a glance. -10n plus 2n is going to be -8n. And then 20 plus 6 is 26. Any questions about that one?